Hello everyone, welcome back to NoSkits. So we are again back with another interesting question of graph from Uber Frequent 52 questions. So let's see what the question says and how we can approach to that problem. So today we are going to solve this question, evaluate division. So first let's read the problem statement and then we'll see how we'll solve this problem. You are given an array of variable pairs equations, an array of real number values where equations I, AI, bi and value I represent an equation AI divided by bi equals to values I. Each AI or bi is a string that represents a single variable. You are also given some queries where queries j is equals to cj comma dj, where jth query where you must find the answer of cj divided by dj is right. So return the answer of all queries. If the single answer cannot be determined, return -1. Note, the input is always valid. You may assume that evaluating the queries will not result in division by 0 and there is no contradiction, right? So first let's try to understand the problem statement, what the problem says, right? Okay, so problem says that we are given equations array, we are given values array and we are given queries array, right? So in the question we are given equations, we are given values and we are given queries, right? Now what equation says? Equation is given in the form of list, right? A comma b, let's say we are also given b comma c, right? And we are also given c comma d, right? So let's say this is the equation array. The values given will be 2, 1 and 3, right? And queries array will contain some queries like a comma c, a comma d, a comma e, x comma, let's say x comma x, and also we are given c comma a, right? So now we are given equations, values and queries. Now equations given in the form of list a comma b and corresponding to each equation we are given a value. So what this means, if you will see this a comma b, there is one value corresponding to it which is 2, right? Which is 2. So that means a divided by b is equals to 2. Similarly, if you will see at this point b comma c, corresponding to it there is one value given which is 1. So we will say b divided by c is equals to 1, right? There is one equation which is c comma d and corresponding to it there is a one value which is 3, right? So these are some equations given and we are also given some queries a comma c, a comma d, a comma e, x comma x and c comma a, right? So now given the equations and the values, we are supposed to find the value for each of the query. So let's take the example of first query. So let's say first query says find out a comma c. So how can you find out a comma c given these equations? So we know a comma b is equals to 2 and b comma c is equals to 1. So can I say a divided by b into b divided by c will be a divided by c, which is equals to a comma c, right? So now what we can do, a comma b is given to us which is 2, b comma c is also given to us, b divided by c which is 1, so the value will be 2, right? So for this query the value will be 2. Now let's talk about a comma d. So now this was the first query. Second query will be a comma d. That means what are we supposed to find? A divided by d, right? So we are given a divided by b into b divided by c into c divided by d. So if you will cancel out these, you will get a divided by d. So the value will be a divided by b into b divided by c into c divided by d will be 2 into 1 into 3, right? So that will be 6. The value for this query will be 6. Now let's talk about this query. So if you will see a comma e, if you will see a comma b, a comma e, right? So there is no e given in the equations. Right? The equation contain a, b, c, c, d, but there is no e, right? There is no e. That means according to the question, if e is not present in it, we should return -1. Right? We should return -1. Now let's move to the next query which is x comma x. Again, is x present in the equations? No, x is not present in the equation. That means the answer to this problem will be -1, right? Let's talk about this query, which is C comma A. So now we are supposed to find the value of C comma A, right? So how can we find C comma A? Can I say that I'll be needing A, right? And I'll be needing C. I'll be needing A and I'll be needing C. So can I reciprocate this? That means, can I say I'll reciprocate this? That means B by A will be 1 by 2 and C by B will be 1 by 1, which is 1 only, right? So A and C, and we reversed it, so B and B, so we'll cancel out this B and we'll get C divided by A. So that means B by A will be 1 comma 2 and this will be 1, so we'll be getting 1 by 2 as a answer, right? So that means some query is given. So we can calculate the opposite of it, right? We can calculate, if A comma C is given, we can calculate C comma A from it, right? If A comma C is given, we can calculate C comma A, right? So if A comma C is 2, we can calculate C comma A as 1 divided by 2. This is a basic mathematic rule, right? So now we know how we can evaluate each of the query, right? We know how we can evaluate each of the query. But how we'll code it? That's the question, right? So what we'll do? So if you'll see, as an input, what is given? We are given equations. As an input, we are given some equation. Equation means there is some relation between these two variables. There is some relation between these two variables, A comma B. There is a relation between A and B, right? What is that relation? If we'll divide A by B, we'll get some value, right? There is a relation between B and C. If we'll divide B by C, we'll get some value. There is a relation between C and D. We'll divide C by D, we'll get some value. That means there is a relationship given, right? And based on these relationships, we want to perform some operation. Based on these relationships, we want to perform some operations. So now, when there is a relationship between something, right? So we can represent those things in the form of graph, right? So let's see how we can represent this in the form of graph and how we can evaluate our queries. So we are given A. There is a relation between A to B, right? There is a relation between B to C, and there is a relation between C to D, right? So A to B, the value is 2, B to C, the value is 1, C to D, the value is 3, right? But we also saw that if A to B is given, that is A by 2 is 2. So we can evaluate B by A as well, which is 1 by 2. So that means we'll have to represent this as well. C by, okay, this will be 1 by 1, right? This will be 1 by 3. So this is how we can represent our equations. We can represent our equations in the form of graph. Now from these equations, from this graph, basically we want to evaluate some queries, right? So let's say we want to evaluate A comma D. A comma D. So what we are doing? For A comma D, if you remember, we multiplied all the three numbers because we started from A comma B and we keep on multiplying C comma D. But why did we do that, right? So we started from A. If we want to evaluate A comma D, we'll start from A, we'll go to B, from B we'll go to C, from C we'll go to D, and at the end when we'll be at D, we'll be having these numbers, right? So this will be 6. So basically what we are doing, based on each of the query, we are simply traversing our graph. From some source to destination, right? So what we are doing, we are starting from A, and we are going till B, till D. We are going till D, from A to B, B to C, and C to D. And when we are going to D, we are keep on multiplying these weights. So if you'll see, this is an example of weighted graph. This is an example of weighted graph, right? Weighted directed graph, right? So this is an example of weighted directed graph. So in which there is an edge, and corresponding to this edge there is this weight given. So if we'll go to A, from A to B, we know the weight is 2. If we'll go from B to C, we know the weight will be 2 into 1, which is 2 again, If we'll go from C to D, the weight will be 2 into 3, that will be 6, right? So this is how we'll start from A and we'll go to this D and we'll keep on calculating our values. So first let's see how we can calculate this graph. So let me explain you this. So we know that corresponding to A, from A we can go to B. From A we can go to B. So we'll be creating adjacency list, right? But there is a weight associated from A to B, right? So what we'll do, we'll create one more key and value pair, that from A we can go to B, but there is one value associated which is 2, right? From B we can go to C and there is one value associated which is 1. From C we can go to D and there is one value associated. Okay, from C we can go to D and there is one value associated which is 3. Now if there is one more edge corresponding to this B, from B to some edge, right? So you'll append this into the same map with, let's say this is X, you will append it X comma and the weight is 4, so you will do this, right? So this is how we can create adjacency list corresponding to this graph, right? Now let's try to code this. So we are given this equation, right? We are given some values and we want to create one graph. So let's create a graph. What we are saying, corresponding to each string, corresponding to each source, we'll be creating one more hash map, right, of string which will be your destination, and there will be one value given. So value will be of type double. So let's create it as double. Now after creating this graph, what we want, we'll traverse this equation and we'll add the vertices and edges to the adjacency list. For int I. Now we have our very first equation. So now we know the first equation will be in the form of this A comma B, right? A comma B, where A and B are the string, right? So what we want to do, corresponding to each of the list, we want to append. So if A comma B, so what we want to do, corresponding to this A, we want to append some weight, let's say it's 2, right? And corresponding to this B, we want to append what? 1 by 2, right? So let's do it. Let's create a hash map of string comma double. This is for, let's say, first one, right? So what we are saying, from the graph we'll get or default, what we want to get, equation get 0 comma new hash map of same type. This will be our first and we want to do it for the second as well. So let's do it. Okay, so after this, what we want, in the first we want to put this corresponding to the value, right? So values ith value, right? Now for second, what we want, 1 by value, right? So what we did, we created the hash map for each of the value for the source and destination, and corresponding to it we added some values, right? After this, let's again put it back to the graph. So graph dot put, for 0 we want to put first and for 1 we want to put second. So now we created the adjacency list, and after this what we want to do, after this we want to traverse for each of the query and we want to run basically a basic traversal, right, from A to B. Now for traversing A to B, you can either use BFS or you can use DFS. I am using DFS, right? So maybe you can give it a try, use BFS, and let me know in the comment section how did you do it. So let's run a for loop for each of the query. Queries dot size I plus plus. Okay, let's get the source and destination. So this will be our source, queries dot get I dot get 0, and this will be our destination. So for this query and for this query, what we saw, that these these should present in our adjacency list. If these are not present, we can directly return -1, right? We can directly return -1. So now we want to return double array. So let's create a double array. Queries.size. Now we'll check if source and if any of this is not present in our adjacency list, we can directly store -1 corresponding to it in our result. Let's initialize one index which will be starting from 0, right? So if source and destination, if any of this is not present, so how we can check? Graph dot contains key source if it is not present, or same for the destination. So we can directly store idx -1. Else we'll call DFS and we'll store the value. We'll call DFS. Now for DFS, what values we want? First of all, we want graph, right? Then we want source, destination, right? And other than source and destination, let's initialize one variable which is 1, which will be passing, right? And yes, we'll be good to go, right? And finally, at the end of it, we can return our result. Also, since we are applying DFS at this point, we'll be needing one visited array, right? So let's create one visited map. So map will be string comma, it will be, let's say, boolean. So it will be visited. We'll be passing this to our function. Okay, since the values will be double, let's do this, right? Okay, now let's write the DFS function. So first of all, DFS will be returning double value, right? DFS taking graph as an input, source and destination as an input, right? And one visited map. And also there is one variable which is double temp, which we initialized as 1, right? Yes. So now what we'll do? In DFS, first of all, we'll mark the source node as visited. So visited dot put source comma true, right? After this, we'll check whether our source is equals to destination. If they both are equal, we can directly return temp, right? If this is not true, we'll do some processing. Now what we did, if source is A and this is D, so we will start our traversal from A, it will go to B, it will go to C, it will go to D. At this point, we'll check whether our source is equals to destination. If this is true, we can return our answer, right? So that's what we did at this point. Now after this, we'll explore each of its neighbor, right? So let's explore each of the neighbor. So let's get the list of neighbors. Okay, it should be double, right? So let's do it. Will be double. Let's get the neighbors list. Graph dot get source, right? Now for we'll traverse over these neighbors, right? So let's do it. Map dot entry set. If neighbor is not visited, right? So neighbor will be this key, right? So if visited dot get entry dot get key, if it is not visited, we'll do some task. Now what is that task? We'll call the DFS. So double call DFS. DFS will be passing graph, will be passing source. So source will get updated to this. We'll get we'll send destination. We'll get temp into the value associated to it, get value, comma, visited. We'll get value. If value is not equals to, if this value is not equals to -1, we'll return value, else we'll return -1. Okay, so we wrote this DFS function. Okay, Okay, so before getting this, let's do one thing. If this is not contained in the map, if this is not contained in the map, we'll do something, right? At the end, we'll return -1. So let's try to run it. Okay, string, this should be capital S and this should be A. Let's try to submit it and it is accepted, right? So first of all, we created our adjacency list. The main task was to create an adjacency list because we have to handle that B opposite case, right? We have to handle this B comma C case. If C comma B is given, we'll have to handle B comma C. So this was the main task to handle in the adjacency list. So now let's try to discuss the time complexity. So let's say number of equations given n, right, and number of queries given m, right. So number of equations and number of queries given m, right. So what we did, first of all, we traversed this set of this equations, right, and we created adjacency list. Now let's say the number of equations contain x, total x unique strings, right, a comma b, right, b comma c and c comma d. So there are a, b and c, 3 unique strings present, right. So let's say these unique strings will be x, right. So now what we did, first of all, we traverse the equations, so it will be n. We created one adjacency list after traversing it, right. And now what we were doing, we were running our DFS function, on each of the query present. So one time running DFS, if we'll run DFS for one time, it takes n time, where n is the number of vertices, right. So we are taking x as a unique number of strings, so x will be number of vertices in our case. So running one time DFS will take x time, but since we are given m queries, it will take x into m time, right. It will take x into m time. So overall time complexity for this will be x into m, right, x into m, where x is the number of strings present, or I can say number of vertices present, m will be the number of queries, right, because the m will contribute to the number of times we are running our DFS call. So this will be our time complexity. Now let's talk about space complexity. So space complexity basically takes e plus v time, right, which is for the adjacency list. Here we are saying x will be our number of nodes, n will be our number of edges, so it will be x plus n time, right, it will be x plus n time, and there will be some stack space, right, that will be in worst case may equal to x number of nodes, right, which is for the stack space. So in this case the time complexity and the space complexity will be this. So I hope you understood this problem, you learned something new from this problem. So that's it for this video. We'll meet in another video with another interesting question. So yeah, that's it for this video. Thank you.